this lesson, we're going to be talking about factoring trinomials. So let's say that we had x plus 2 times x plus 3. So let's say we had these two binomials, and I wanted you to multiply them together. I would do x times x would give me x squared, and then x times 3 would be 3x, and then 2 times x would be 2x, and then 2 times 3 is 6. So I have my front, I have my back, and then the 2 in the middle would always go together, and that makes 5x. Now, I end up with x squared plus 5x plus 6. And I can visually see that this x squared comes from the front being multiplied together. So x times x gives me the x squared. So the front comes from the fronts of your binomials. The back number also comes from the back numbers being multiplied. So 2 times 3 is 6, and that makes my back number. The middle is made up of the outside two numbers and the inside two numbers. So these two numbers have to multiply to make this 6, but they also have to add together to make the middle number. So when we factor, the first thing we always want to look for is a greatest common factor. That should always be the first question we ask ourselves. So just going to kind of go over greatest common factor again. Greatest common factor is the largest number that we can divide out of the terms that we have. So if I look at number 1, I have 5x squared, 15x, and 10. So all of them have 5 in common. I can divide 5 out of all 3 of those. So I'm going to take and divide 5 out of each one. 5x squared divided by 5 is x squared. 15x divided by 5 is 3x. And 10 divided by 5 is 2. All right, if I look at number 2, I can see that I have 4 and 8, which have 4 in common. But I also have an x squared and an x to the first. So I can divide an x from both of them. So 4x squared divided by 4x is x, and negative 8x divided by 4x is negative 2. Now, when you factor something out, essentially you're just kind of like taking it apart and dividing it out of what you originally had. If I were to multiply these back together, I should get what I originally had in my problem. So if I distribute the 5 and do 5 times x squared, I should get 5x squared. 5 times 3x, 15x. 5 times 2, 10. It should be able to multiply back together to get what I had. So when you have a trinomial, we have some rules here. When there is a plus at the back, now when I say at the back, this is the sign at the back. And when I say the sign at the front, I'm talking about the sign at the front, okay? So if you have a plus at the back, so if I look back here and I have a plus sign, I'm going to immediately look up front, and I know that when I factor, my binomials are both going to have a plus sign. Whereas in this second kind of example here, if there's a plus sign back there, I look up front, there's a minus sign, so I know that both my binomials will have a minus. When there's a minus at the back, it does not matter what's at the front. Okay, you can have a plus at the front, that's fine. You're still going to have one parenthesis set that has a plus and one that has a minus. Same thing here. I see there's a minus at the back. I don't need to know what's up front. I'm automatically going to have a positive and a negative. So number 3, I'm going to factor this binomial. So first thing I'm going to do is put my signs in here. So there's a plus at the back. So I'm going to look up front, and I see that I have a plus sign, so both of my binomials will have a plus. I also know that my front has to multiply to make the front number. Well, the front number is x squared. So to get an x squared, I would just have x times x. The two numbers at the back are going to have to multiply to make the back number. So I'm going to list out what multiplies to make 2. Well, 2 is prime, so it's just 1 times 2. But that number combination is also going to have to add to make this number in the middle. Now, if this was a minus sign back here, it would have to subtract to make that number in the middle. So I'm adding to make 3. 2 and 1 do add to make 3. So those are the two numbers I'm using. Since I have x plus and x plus, it doesn't matter where I put the 2 and where I put the 1. And now I am completely factored. So number 4, again, I'm going to look for a common factor. I know that on these first ones, because I've made these notes, that there is no common factor on these. But you should always ask yourself that first. Is there a common factor? No, there is not. So I'm going to immediately go ahead and factor this. I look at the back and see that there's a plus, so I look up front. I have a positive, so 2 plus signs. I also know to get x squared, I need x times x. Now the back numbers have to multiply to make 16. Well, what multiplies to make 16? We have 1 and 16, 2 and 8, 4 and 4. I need the combination that will add to make 10. Well, that would be 8 and 2. That adds to make 10. Again, since these are exactly the same, it doesn't matter where I put 8 and where I put 2. All right, number 5, no common factor. But this time I have a minus at the back, so I automatically have 1 positive and 1 negative. To get that x squared, I have x times x. And then the back two numbers have to multiply to make 21. So I'm going to list everything that makes 21. 1 times 21. 21 doesn't divide by 2. Doesn't divide, 3. 3 and 7. Doesn't divide by 4. Doesn't divide by 5. Doesn't divide by 6. And we've met in the middle. That's all that was between these two numbers. So I need the combination that will subtract to make a positive 4. Well, if I do 3 and negative 7, that makes a negative 4. But if I do negative 3 and positive 7, that makes a positive 4. So I need the 3 to be with the negative sign and the 7 to be with the positive. So when your signs are different, you really have to pay attention to where those numbers go. So if I look at number 6, no common factor. I have a minus at the back, so automatically 1 positive, 1 negative. To get that x squared, I have x times x. And the two back numbers have to multiply to make 8. So 8 is 1 and 8 or 2 and 4. I need the combination that will subtract to make a positive 7. Well, that would be 8 and 1. To get a positive 7, though, I need 8 to be positive and 1 to be negative. All right, no common factors on 7. But I see I have a minus at the back, so 1 positive, 1 negative. I have a v squared, so v and v. And what multiplies to make 42 needs to go at the back. So 42. I've got 1 and 42, 2 and 21, 6 and 7. I need the one that will subtract to make a negative 1. Well, the only thing that subtracts to make 1 is this. And if I want a negative 1, then I need 6 to be positive and 7 to be negative, because 7 and negative 7 and 6 will make negative 1. All right. Again, no common factors on number 8. We have a minus at the back, so 1 positive, 1 negative. I need an x squared in the front, so x times x. And I need numbers at the back to multiply to make 15. So that gives me 1 and 15, 3 and 5. I need them to subtract to make a positive 2. That would be 5 and 3, and I need 5 to be positive and 3 to be negative. All right, no common factors on number 9. I see I have a plus at the back, so that's 2 of what we have up front. So this has 2 minus signs. This is supposed to be an x, but I have a typo. All right, and then I have x and x. And then I need 2 numbers that multiply to make the 3 back here. Well, the only thing that multiplies to make 3, since it's prime, is 1 and 3. Do the 1 and 3 add to make 4? Yes. And since these parentheses are exactly the same, it doesn't matter where I put 1 and where I put 3, as long as I have them both. Now, when there's not a 1 in front, things get a little, more complicated, but we just have a couple of extra steps. So first thing, I'm going to make sure that I don't have a common factor. I have 4x squared, 13x, and 3, no common factors. So I need a 1 in the front if I want to use those rules that we just practiced for factoring. So I'm going to do what we call the illegal move. I'm going to take 4 and I'm going to move it and multiply it times the number at the back. So I have x squared plus 13x plus 12. And then I'm going to factor this just like we've been doing. So I look at the back, I have a plus. So I look up front, 2 plus signs. I have my x and my x. What multiplies to make 12? Well, I have 1 times 12, 2 times 6, 3 times 4. And I need the combination that will add to make 13. All right? That would be 12 and 1. And again, these are exactly the same, so it doesn't matter where I put 12 and where I put the 1. However, if I multiplied those two binomials together right there, I'm not going to get what I originally had because x times x is not 4x squared. So I have to undo what I did in the beginning. I moved this 4 by multiplying it. So I'm going to divide both of these numbers by 4. If they reduce or simplify, I should do that. So 12 divided by 4 will simplify to 3. 1 divided by 4 does not reduce, so I'm going to take that bottom number, that 4, and I'm going to move it in front of the x. And now I have my factored state. The 1 just stays behind back there. All right, so at number 11, again, no common factors. So I'm going to take this 3 and multiply it times the 2. So I have x squared minus 7x plus 6. And I'm going to factor this just like normal. So I have a plus at the back. I look up front, 2 minus signs. I have x and x. And I'm looking for two numbers that multiply to make 6. So 1 and 6 or 2 and 3. And I need the combination that will add to make 7. That would be 6 and 1. Since these are exactly the same, doesn't matter where I put the 6 and where I put the 1. But again, I can't stop here because if I multiplied them together, I would not get what I originally had. X times x does not make 3x squared. So I need to divide both of these by the number that I moved. I moved the 3 by multiplying by 3. So I'm going to divide both numbers by 3. 1/3 does not reduce, so I'm going to take the 3 on the bottom and pull it in front of the x. So I have 3x minus, and then the 1 stays behind. 6 divided by 3 makes 2, so x minus 2. All right. Now, number 12. I don't have a common factor. However, I do have this negative in the front, and we don't like that. So we're going to divide everything by negative 1. So negative 4x squared divided by negative 1 is 4x squared. Negative 8x divided by negative 1 is positive 8x. 5 divided by negative 1 is negative 5. It essentially just changes the sign of everything, but we need that negative out front. All right, I still have that 4 in the front, so I'm going to take it times the 5 at the back. So I have x squared plus 8x minus 20. And then I'm going to factor this just like I have been. I have a minus at the back, so 1 positive, 1 negative, no matter what. I have x and x. And I'm looking for numbers that multiply to make 20. So 1 and 20, 2 and 10, 4 and 5. All right, and they have to subtract to make 8. Well, I have 10 and 2, but I need it to be a positive 8, so that means my 10 has to be positive and my 2 has to be negative. Now again, I did the illegal move, so I'm going to divide both of these by 4. If they reduce, you should reduce them. 10 over 4 reduces to 5 over 2, and 2 over 4 reduces to 1/2. Now I can pull those numbers in front of the x, the ones that are left on the bottom. So I get 2x plus 5 and 2x minus 1. Number 13 does have a common factor of 4, so I'm going to factor out 4. That gives me 4x squared divided by 4 is x squared. 32x divided by 4 is 8x, and 60 divided by 4 is 15. And now I no longer have that number in front of my x squared. So I'm just going to factor this like normal. I have two plus signs because there's a plus sign at the back. I looked up front. There's a plus sign. X and x. And I'm looking for two numbers that are going to multiply to make the 15. So I have 1 and 15 or 3 and 5. I need the one that will add to make 8. That would be 5 and 3. And these are exactly the same, so it doesn't matter where 5 goes and where 3 goes. All right, number 14, I do not have a common factor, but again, I have that negative out front that I don't like. So I'm going to factor out a negative 1. Negative 2x squared divided by negative 1 is 2x squared. Negative 5x divided by negative 1 is positive 5x. Negative 3 divided by negative 1 is positive 3. Then I can factor, but I still have a 2 in front, so we're going to do the illegal move. So if I move that, I have x squared plus 5x, and then 3 times 2 is 6. And I factor that just like normal. So plus sign at the back means 2 of what's up front, and we have a plus sign up there. We have x and x, and I'm looking for two numbers that multiply to make 6. So that's either 1 and 6 or 2 and 3. But they also have to add to make 5. So that would be the 3 and the 2. Doesn't matter where they go because both of these are x plus, x plus. But then I have to divide both numbers by 2. If they reduce, you reduce. 3 over 2 does not reduce, so I pull that 2 in front and leave the 3 behind. 2 divided by 2 will reduce to 1, and now I am factored. Sometimes you might factor out a common factor, and then you can't find two numbers that will multiply to make that back number that also add or subtract to make the middle number. In that case, the only way to factor that would be to just take out the common factor. Some things cannot be factored. So you may run across trinomials or binomials that have no way of factoring a common factor or no way of factoring into two binomials, and that's okay. It just means it can't be factored.